Alright, so we'll be continuing on with some of the technical thinking that we've been covering in the previous section, and we're in the technical tools. And the side that we're focusing on for these sections is the tools to improve, which is really the skill side of the more technical aspect of this lean transformation. So in these first couple sections, the tools that we've covered already to this point have been stability, we reviewed problem solving, looked at standardized work in Heijunka, and then what we'll be covering now is this this concept of Heijunka. And really all Heijunka is it's a method, it's a smart method of production leveling. And the reason we want to level production is pretty straightforward once we actually kind of think about it. So if we lay out on this chart, this white line, say that's our customer orders, our customer demand. And that's something that everyone can relate to. You know, our sales aren't the exact same from day to day. Sometimes we have to fill a bunch of orders, sometimes we have a really slow day, we don't have very many orders, sometimes it's in between. And so if we chart it day to day, in most cases, you know, it's pretty unbalanced, and you can have really busy and you can have really slow and kind of everywhere in between. And as a result, if we wanted to staff appropriately so that our customers didn't have to wait and we could always fulfill our promises and build everything that was ordered when it was ordered, that leaves us with a pretty wide range, right? Because we have to have a lot of people available for those really busy days, but then when everything's really slow, we really don't need that many people. And that's a pretty wide range, and that can make it difficult to staff appropriately, because if we have too many people, then they're waiting when it's slow. And if we don't have enough, then of course we fall way behind when things get busy. So this idea of Heijunka is what we use to help address that in a smart way. And really what Heijunka thinking is it's kind of a way to understand our production sequence, to kind of balance it, and specifically balance it by volume and style. And as a result of that, kind of our goal is once we can perform that leveling, what we want to try and do is just balance out and kind of shrink those peaks and valleys in terms of what our production requirements are, so that our resource requirement isn't quite so varied. And in true ideal thinking, what we want to do is we want that minimum requirement. We want to set up our production so that we can meet that minimum requirement with our regular work days. And then we want to balance appropriately so that when we do have an upswing, we can meet that with just regular overtime. You know, maybe a half an hour or an hour at the end of a shift. You know, not a whole weekend, or, you know, add a second shift, things like that, right? We want to be able to balance our production so that we can kind of shrink those instabilities, you know, stabilize what our requirements are, and then we want to design our processes so that we have the right amount of people to fulfill what the demands are. That's what Heijunka lets us do. And so the first thing we're going to look at is leveling production by volume. That's the first thing we want to do. And how do we go about doing it? We use this notion of takt time, which we first covered in the standardized work section. But just as a quick review, really what takt time lets us do is it lets us figure out how long we should take to produce every unit based off how many we have to make and how long we have to make them. It's pretty straightforward. So in this case, we need to make 1,824 units a month. We work 16 days a month, 114 units a day. We have one shift per day with a lunch break, couple breaks. That's 570 minutes of actual work time, right? We don't want to include breaks and lunch because we're not working then. We only want to think of actual work time. So then our takt time, we know we need 114 units, and we know we have 570 minutes to make each unit. So that means every 5 minutes we need to have a unit finished to make sure that in balanced production we meet our demand requirements. And so when we look at you know, when we need to produce maybe more than one style, because it's not very many facilities just produce one product all the time and that's all they run. Almost everybody runs at least a couple different versions and a couple different products. And so kind of the traditional way of going about that is batch building, right? We want to be more efficient, so we want to set everything up once and run all of type A, do one changeover, run all of type B, and do one changeover and run all of type C, right? That's the typical way to go about it. So we'll mock that up in an example, and here essentially we're saying out of our 114 units, we'll run 56 of type A, 29 of type B, and 29 of type C. And our production sequence is just batch. All A, then B, then C, and then we're done. And so what are the effects of that, though? That's really what we want to understand in terms of how we're trying to balance. And so we're just going to lay out just kind of a mock production process. And so we have three supplier processes upstream, maybe subassembly or paint or some sheet metal, welding, whatever it could be. But we've got three of them. And each one of those supplier processes now feeds our final production line. So in an office environment, maybe you have a couple other people in the office that are preparing documents or that have to sign off on something first or collate things or get things ready before it can actually now enter the main flow where they're processed and completed and sent out the door. And then at the end of it, of course, we ship our product. And so when we look at what does takt time mean in the context of how we produce, takt time really means that every 5 minutes in this case, because that was our takt time, we're going to have a steady withdrawal from the end of our production line at that 5 minutes. So every 5 minutes we're going to be taking one unit, and then 5 minutes later we're going to take another unit, and 5 minutes later we're going to take another unit. But it's steady and it's constant. And so then when we think about that, well, what does that mean for our supplier processes, right? If our main assembly line has to produce one unit every 5 minutes, well, that means that our supplier processes need to get them the material they need at least every 5 minutes, right? Otherwise, we're going to shut the line down, and that's not what anybody wants. And so if we're looking at that and we know that's our goal, how are we going to go about doing this with batch production? That's what we're going to look at first. So there's a couple different ways we can manage that. And in this first example, again, we'll lay out our sample factory here. So we've got our final assembly line, we've got our shipping department, and here's our shipping schedule, right? Batch building. With takt time of 5 minutes, every 5 minutes we're shipping one product, and we're going to batch build, so we're going to do all our A's, all our B's, and then all our C's. So every 5 minutes we're drawing from the end of the line. Now, we'll look at our first subassembly or our supplier process in A. We're going to build 56 of them. That cycle time there is how long it takes to make each unit of A in that supplier process, right? So that cycle time means it takes 10 minutes. Every time it takes 10 minutes to build one A unit to send it down the line so that the final line can get it out the door, right? And if we remember back to what takt time lets us do is, okay, if it takes 10 minutes to build it, and we know that we need to have one finished every 5 minutes, well, 10 minutes divided by 5 minutes is 2, so we know we need 2 people working there in order to get one out every 5 minutes, right? Pretty straightforward. So we have 2 people working in the station to make all of those A's, and they're doing great. And every 5 minutes they get one done until we finish all of the A's and we get ready to switch over to B. Now we get started on B, and we only have to make 29 of those. But there's a problem. The cycle time for B is 20 minutes. The B part is twice as complicated. It takes twice as long to make. Well, if we still have to get one to the line every 5 minutes so we don't shut the whole factory down, now 20 minutes divided by 5 is 4. So now we have to have 4 people there working to get product to the line. Not too bad, but it's a little bit of hassle. Where are those other 2 people going to come from? Are we going to have to tell them to stop everything they're doing and get them to run across, like a 5-alarm fire to come help out now at B so we don't shut the line down? Or are we going to have them just sitting around most of the day in case they're needed? These are some of the issues in terms of trying to manage this. So we finish our B's, and now we get to our C's. And now we run into a real problem, because the C is the most complicated version we make. It takes 40 minutes to make each C. So 40 minutes divided by 5, our takt time, means now we got to get 8 people together to come and build these parts, just 29 of them, to get them to the line so we don't shut production down. So when we look at that, the big thing here is, where's the waste? And the problem we have with this, and I think it becomes pretty easy to see, is how are we going to deal with getting all these people together, getting them in, getting them out? Where are they going to come from? What are they going to do when they're not working? So when we're not running C's, what do those other 4 to 6 people go do? That's the type of waste we have. Idle, there's not enough work, we're not really managing smartly our people. Plus, it's really difficult to be organized about that. I think everyone would agree if we tried to do this in real life, or if you have tried to do it in real life, you end up with difficulties in trying to coordinate people. Things get shut down, things are late, people are standing around. It's a lot of frustration and it's a lot of waste. So maybe we'll try and look at this a different way, right? We've got some issues with trying to shuffle that many people around, or even hiring that many people to begin with. So maybe that's not the best thing we want to do. Well, what's another approach we could take? Well, we'll set up our same schedule, batch building again, but this time, instead of building directly to the line, one by one, just-in-time production, we're just going to build the inventory. It's the little hat with the slash. That's inventory. So we'll have one person in Station A, full-time, 40 hours a week. Every day they're there doing nothing but building A parts and putting them in a big pile. Now we'll have the same thing, excuse me, we'll have the same thing for B, because we only need to build half as many Bs per day. That's our schedule. We have one person at B building to a big pile of Bs. And then at the same thing for C, we need half as many C's as A's, but they take, again, 40 minutes, so we got 2 people there. The math is pretty straightforward. I think if you're struggling with that, it's good to just pause the presentation here and just kind of work it out on your own so you can make sure you're following. But the reason we have 2 people there at C is, one, we only need to make 29 parts, so it's half of the requirement for A, but then because the cycle time is 40 minutes, which is twice the cycle time of B, we need that extra person there to make sure we're making enough parts. So that's our plan now. We're just, instead of trying to shuffle people in and out, we're just going to leave people there permanently and have them all build the big piles of inventory. And then, as we go through our schedule, that final line is just now going to pull from all that inventory. So we looked at it good. We said, all right, great. We solved this issue with the people, but where's the waste here? And the big thing that jumps out here is now we're building this inventory. And if we remember back to the talk about stability, what is our traditional kind of knee-jerk reaction to deal with problems? Well, we add capacity. And adding inventory is adding capacity. We don't have a smart way to try and get exactly what we need to the line, and since trying to shuffle all these people around is a real challenge, we'll just cover up that problem by just adding capacity and adding more inventory. Now, the concept of inventory, of whether it's bad, whether it is waste, is kind of a lengthy discussion. We covered it some in the philosophy section, but if you really think about it, is that even though we put this inventory there, and yes, even though we may use it, sometimes what if a canceled order or something like that happens, we may not, we may be stuck, that money may be wasted. But if we think about building up an inventory, well, what happens if we have a design change? Now we have to rework it. What happens if we find a defect? Now we have to inspect it all. What happens now that we've said, you people, your team members do nothing but build this? Well, what about the opportunity cost? What about our other customers that needed something over here that we didn't build because our people were building to a pile of inventory that we don't even need yet, right? So there's lots of problems associated with building up inventory as a band-aid for some of the other problems that we're having. And so what that kind of leaves us with is, well, if we just level by volume, right, just to that tack time, we either have these issues with trying to shuffle a whole bunch of people in and out, or we have to build a whole bunch of inventory to compensate. And neither of those are really that effective. So what we do is we want to level by volume and style, right? That gets into to understanding our production sequence. And so what that looks like as an alternative to this batch building, which comes naturally, is that here's a new sample schedule. So we know how long it takes us to make part A and part B and part C. So let's change our sequence up. And by changing this sequence, now we have some new production requirements. Instead of, remember when we built in a batch, when we were building Bs, they needed a B every 5 minutes. And when we were building Cs, they needed a C every 5 minutes. But when we rotate and we change the schedule like this, now you can just go right across. So 5 minutes to 15 minutes to 25 minutes. They need the final assembly line needs an A part every 10 minutes. Now when you go to B, 10 minutes to 30 minutes. Well, they need a B, now they only need a B every 20 minutes. The same for the C. And by sequencing like that, over the course of the day, we still get all the parts out that we needed to make, but now we've changed the demand for how quickly our supplier processes have to get those parts to the line. That's the key thought. When we batch build, now everything has to be made at the same speed. When we balance and level by style, now we have some flexibility to address the issues with our supplier processes. That's kind of the key thought out of this. So what we really do now with that is something called sequence production. So here's the third example. We'll set up our line, but you can see there our shipping schedule has changed. Now we're not doing just batch building, all A's, all B's, all C's. We're kind of changing our sequence there. Well, what that allows us to do now is, just like before when we were building the inventory, with our tack time, we know that they're going to need an A part every 10 minutes. Well, if the cycle time takes 10 minutes for A, Great, we know we need one person. We know they need a B part every 20 minutes. Cycle time for Bs, 20 minutes. Great, we got one person working there full time, we'll be in good shape. Cycle time for Cs, also 20 minutes. Or the takt time, I apologize, how often they need it. Cycle time there is 40 minutes though, so for Cs, we have 2 people there, just like when we were building to inventory. But the difference is now, because we've changed the sequence that the final line is pulling from them, we don't have to build up those huge inventory reserves. Because with just these people, the way it's laid out, because we've changed the rate at which the line is withdrawing from those supplier processes, now we've taken the whole pressure off of them trying to keep up. We've eliminated that inventory stock. That's really what we're after. That's the value of sequencing our production and being smart about how we make our schedules. So when we look at it, did we make an improvement? And I think what should jump out is, unlike the very first example where we had to throw a ton of people at it to try and keep up, we've minimized our manpower here. And unlike the second example, where because we were building in batches and we needed all those C's right in a row and all those B's right in a row and it was hard to keep up, we had to build those big inventory stockpiles. Well, now because we've changed the sequence, now we've eliminated all that inventory. So when we level by volume and by style, and we can think through the way we schedule and produce this way, we can minimize our manpower and we can eliminate having to build up inventory to compensate for all this stuff. And that's the real value out of this. That's where we get the efficiency out. And so just another way to look at that in terms of just pure manpower efficiency, because that's what we're chasing with Heijunka. So before Heijunka, if we batch build, right? Because that was kind of the traditional approach. So we've got 3 different parts that we're making, C, B, and A. And C takes the longest, B is right in the middle, and A takes the least amount of time. Well, our takt time says we have to produce every so often to make sure we get all our parts done. The B parts take takt time, so that's fine. C's take too long. A's, on the other hand, take less time than we actually need. So if we batch build like this, in order to prevent falling way behind whenever we run C parts, we have to staff for that max production at C. But what ends up happening now when we run A's or B's? Now we've got people that are standing around, we have people that are waiting, we have lost time, we have waste, right? That's the problem here. That unbalance, and it causes that waiting. And that's the real issue with batch building like this. Now after Heijunka, when we look at, all right, let's level our production, let's by sequence, let's change it. So here, instead of building all C's, then all B's, then all A's, we'll do one of each in order. We lay out our takt time, and what we can see now is all we have to do is staff to that weighted average of the 3. Because we can see as we go through on this production schedule, they're going to fall a little bit behind on C, B will be fine, but now because they finish A early, they'll catch right back up. Then they'll fall behind on C, B will be fine, they'll catch up on A. And because we can do that, on the average, we'll be done on time, but look at how much fewer people we had to staff for. How much we were able to reduce our resource requirements because we were smart about how we actually produce things. That's the goal with Heijunka. That's what we're really after. That's the key thinking out of this. Now this also works on a conveyor belt. And this is just a quick example of that. So we lay out a quick conveyor. We set up a couple pitches, a couple workstations. There's our one sample process. So here's our takt time, and this is our production sequence. We're going to go A, C, B. So we'll set the line in motion. First part comes down, it's A. We actually finish it early. So instead of just waiting around, now we can go back and start on C a little bit early. So we catch C early, we follow it down the line, and we finish C right on time. Then we can go back, we start B, finish B on time, and go back to start A. So even on a conveyor system, right, this idea of balancing. So if some things take less time than other things, we balance them so that on the weighted average, everything comes out to takt time, and we don't have to compensate by building up huge inventory stockpiles or having a bunch of extra people on hand just in case we need them, right? That's what we're trying to get at. So in summary, what we want to do is, again, just to hit on it one more time, is we want to kind of sequence and level our production by volume and style, both of those together. That's critical. And when we can do that, it makes our production waste visible. We can see it in our manpower. Do we have more people than we need? Are we overstaffing because of how we're producing? And then we can also see it with inventory. Are we building up more inventory than we need and wasting money on big inventory stockpiles because we're not planning our production smartly? And then kind of the last thing, the benefits that come out of this when we can do it, and when we do it, is we have a much better distribution of our labor in terms of efficiency. We have our team members where they need to be. We understand why they need to be there. We don't have too much. We don't have too little. We have the right amount, and we're smart about it. We can also reduce our machine requirements, right? Because we don't have to purchase, just like people, we don't now have to purchase 10 times the equipment we need to run just one type of part, because when we batch build, we got to get it really fast, right? We can use that weighted averaging to make sure that on the whole, we have just the right amount. And then the last thing, again, to hit on it one more time, is we reduce our inventory requirements. Because when we sequence by variety, remember, we can pull from our supplier processes in different time intervals to make it easy for them to produce what we need without having to have them running and building everything into a warehouse all the time. And that's the real value out of this. Minimum manpower, minimum inventory, maximum efficiency. That's what we're chasing with Heijunka. So like everything else, any questions, direct them through the web. This one in particular, I recommend maybe going through it 1 or 2 times, pausing it, checking the math, and just making sure everything kind of clicks, because it's a little bit of a departure sometimes. Especially if it's something that's totally new. So it's worth it to kind of think through it a couple times just to make sure that everybody really fully understands it. And in addition, just kind of as a follow-up, we talked about moving away from batch building, and there are some other concerns in terms of changeover time, things like that do make batch building attractive, that we will address in the next couple sections in terms of how we get around that, so that we can use Heijunka, so that we can minimize our manpower and we can minimize our inventory. So we'll cover those in subsequent sections. Thanks.